Welcome back. So I'm going to be doing a video here debunking Nathan Thompson again. Flat earther. He's a bit of an ass. He thinks he's dead clever, but he really isn't. And I'm going to take what he uses his best flat earth proof, and we're about to destroy it. Have fun. Let's go and see what we have.
Do you know how much the earth should curve over 1 mile, Grieve? We'll have a conversation now.
That's because this fella went up on a panel, and all these flat earthers did is start asking him if he drinks his water off of a ball or if he drinks out of a cup, and laughing at him. And that was probably about the best that they really had for anything sort of intelligent, because the rest of it here was just a load of crap.
Grieve.
Yes, sorry.
No worries. You know how much the earth is curved? Yeah, the earth, it's allegedly curving in all directions. I couldn't find it for 8 years. I was wondering if you know how much it should curve.
So this is usually when Nathan Thompson starts, which he then segues into he's got two different things he uses all the time to try to prove the earth is flat. I've been up on the panel, he tried to use them, and he didn't like it when I started pointing out some of the inconsistencies in his panel, and then he kicked me and blocked me out of the live. It wasn't his live, it was actually somebody else. He likes to hijack other people's lives. But really the idea he asks is how much you should curve. Now the obviously question would be, well, from what observer height, you know? He wants to know how far it's curving and stuff, but that all depends on your altitude. The higher you're up, the further you're going to be able to see until you're going to see over top the curvature, so you're going to see further before you're going to start noticing things being obstructed by the curvature of the earth. But Nathan doesn't like to do that, because as soon as you brought that up, then he kind of gets pissed off because you start asking questions he doesn't like, and then he probably would kick Grieve.
Well, that's got variables as well, doesn't it? Because the land mass isn't flat. It has mountains, hills, man-made levels.
That's called the topography.
Yeah, it's got ball lickers too.
So depending on where you conduct your experiment, you're gonna find you've got varying results.
Right on. I just asked a simple question.
You're gonna have. Yeah, but simple questions are answered simply to simple minds. If you don't understand,
I asked very direct questions to Globers. Listen, bro, I asked very direct questions to Globers because I know Globers very well. I've studied them for the last 10 years.
He actually doesn't know the globe very well, or if he does, he pretends he doesn't. For the last 10 years, he's just been spreading lies and chasing children around on playgrounds and chasing women around in parks, shouting at them and trying to spread his misinformation and his utter complete nonsense and BS fantasy flat pancake dirt pizza.
So I asked, do you know how much Earth curves over 1 mile? The correct answer would be yes, and then how much it curves, or I don't know.
Yeah, let me try this. Nathan, did you go to the store today?
No, I haven't been to the store yet.
All right, that's a simple question, simple answer, not hard.
No, but I tried to.
You just go around about in a circle.
No, but if I stood on a plate and went to the store, you know.
Okay, all right. So for your maths, it's your standard 8 inch per mile.
Now here's the thing: if you're actually looking for curvature in any kind of trigonometry, or if you're using any kind of geometry and stuff, curvature isn't measured in miles, it's actually measured in degrees of curvature, right? So you actually look at degrees. Now the earth curves 1 degree per 69 miles, or 1 degree per 60 nautical miles, and that's how much curvature is actually measured. Now what they're talking about, the 8 inches per mile squared is what she's looking for. That's actually measured drop off a tangent. So that's only an approximation, and it's designed for if you're laying flat. It only works at sea level, so it doesn't come from the altitude. Altitude completely, you can't use 8 inches per mile squared. And so if you're laying flat, so you have to be straight on the ground, and you're looking straight out, and then it's measuring 8 inches per mile squared off that, and it's just a drop off the tangent, so it's going straight, and it's the drop underneath there. That's what all that is. That's all it's good for, is approximation. It's only really accurate up to about 1,000 miles, anything past that, because it's actually off a parabola. It's not actually even for a sphere or a circle, anything like that. But it's only accurate is if you're at sea level, and if you're laying on the ground, it's not from ground level, looking straight out, and it's a drop off of a tangent. So it doesn't account for observer height, doesn't account for obviously altitude, doesn't account for atmospheric refraction, and doesn't account for how we actually look. If you're looking up higher, you can see, you can look down a bit, you're actually looking, you can see, we don't look straight, we actually follow our eyes. We look at you'll see the curve, the horizon, and we look over the horizon and see what's past the horizon, if anything's up past the horizon. So 8 inches per mile squared is only an approximation, and it's actually not very accurate, and there's a lot of caveats to it. But flat earthers like to latch onto this and try to use it because they use simplified curvature calculators that only rely on just 8 inches per mile squared and don't take any other factors into account, and they latch onto that because they think that helps prove the flat Earth.
Nathan's waiting for his compass to process all around again.
Sorry?
He's waiting for his compass to process. Then he can go to the store.
So 8 inches per mile, and that would be exponential. So at 10 miles, you would see 66 feet of curvature. We don't observe that, but I'm curious how far.
Yeah, look.
Like I said, just to reiterate that 8 inches per mile squared is only accurate at sea level from laying flat on the ground, and it's drop off a tangent, looking straight out. It doesn't take any observer height, altitude, atmospheric conditions, or anything else into account. It's a very simplified equation, which is why flat earthers like it, because math is very confusing to them.
Grieve, last question I got for Grieve. Grieve, how far?
Oh my god.
There we go.
Yeah.
Go.
It looks like he's fixing a bowl of turkey.
He drinks water. That's how he drinks water.
That with the gold.
Wilbur's drink water.
So, Grieve, do you know how far the horizon would be? This is my last question to make sure you're qualified to have this conversation.
At what's the observer height?
You could give me a 1 or 6 foot observer height.
About 4 or 5 miles.
Excellent. I'm so glad you said that. Can I get the big box, please, guys?
All right, now we're going to see Nathan's this is where he comes up with his little flat Earth proofs that he uses all the time, which are just down to includities and the fact that I think he just misrepresents these. They've been explained several times, but he ignores it all. So let's see his first proof, and then we're going.
So here's a bottom picture, 1 foot observer. You just told everyone it'd be 4 miles away. Well, that platform on the left is 9.4 miles away. So I don't want to call it.
The observer height is much more than 6 feet.
No, it's a 1 foot observer height, sir.
That is definitely not 1 foot of height.
Yeah, I can show you another one.
Yeah, we
You're
all seen
lying.
the video of it. It's 1 foot observer height, bro. There's a video. It's not just a picture.
That is not 1 foot observer height.
All right, I'll show you another one. Hold on.
That's an outright lie.
So top image is one that Nathan likes to show all the time. Unfortunately, he ignores the other image in which refraction was nearly as strong and wasn't as extreme, and you can see that it actually suits and fits the globe perfectly. So his first one is completely debunked.
I mean, you're assuming he's lying.
No,
Not really. You don't have any evidence of your own picture. Calm down. I'm just saying. Factually basis. I mean, you could be right. You could be wrong. I'm just saying. There's no way for you to know without going to the same location, doing the same test. You're just assuming it's a lie.
Yeah, you can watch this whole video on my page right here. 9 miles, 7 miles, 5 miles, 3 miles. This is also a 1 foot observation height. So the horizon should be right around here, 1.2 miles. And it's way past here, 9 miles. I don't know exactly how far it is, but you can see this light and all these other lights, and this light and all these other lights should be obstructed by the curvature that doesn't exist. Thanks for playing.
Yeah.
Right, so Nathan thinks that's it. match set, but he doesn't quite know a few different things. So one, that was over a frozen lake. Two, the observations from that, because I've actually watched that. It's not on his YouTube channel, because on his TikTok, because I watched the YouTube, and it's like a 6-part series to try to show that. So yeah, he's bullcrap there. And also that's so he's not taking into the lapse rate, the refraction on the frozen lake that was done. And also I think there's different observations. One was done in the back of a pickup truck, which was a jacked up Toyota Tacoma, and it was about 6 feet high because it was quite high up. He did have his back window. And then the other one is that he did go a little lower down. I don't think it was a foot, may have been. It was that he used some pylons. But that's completely actually explainable. For one, light doesn't stay in one little point. Those were just some trailer lights, and as light goes out, it expands out, right? Light kind of diverges away from the source. And you're diverging going to the cone. So I'm going to play a little video here from a fellow called something light, and he is a surveyor, as well as a few other people that actually know a lot about this, and he explains it really well. So
Waterman has a fantastic question here. Why are the lights at 5, 6, 7, and 8 miles visible? And the answer is because number one, these lasers output in a cone, and so by the time these lasers are 1 mile away.
God, don't mean to embarrass you. There's no laser in that observation. My God, wake up!
It's just colored trailer lights.
There's no laser. Wake up!
All right, well, Dan, calm down. Well, yeah, sorry, Dan. Tell you what.
I'm tired of people's assumptions.
Here's what I'm gonna do, Dan. I'm gonna ask Sea Lion. Will you do the same, please? Mute him so that I can talk uninterrupted to give him an answer. Okay, thank you.
Yeah. I just
whatever the source is. So, if it's not a laser, it's even worse. But a laser at 1 mile will have a rather large cone of light, and it gets larger and larger. A light, rather than a laser, has an even larger cone of light. It emanates it's an isotropic potentially. So the light goes in all directions from those from the light source. So the very steep gradient, as I just demonstrated, over cold water. Now this is, I believe, is this frozen water or is it liquid water? It doesn't really matter. You get the similar gradients in the temperature at those low elevations, up to 2-3 meters. So you get very steep gradients, and so the light that's aimed somewhat up will still get enough, will get refracted so that it gets to you. There's nothing at all challenging about the light refracting like that to get to the observer. If you wanted to do a meaningful observation, do it in the morning on an overcast day potentially. Shoebill could give a little more details on optimal conditions, and then don't just shine a laser. Get a target and a theodolite of some sort, or even a target and a camera, and see if you can make out the target clearly at that distance. So that's what I would say you'd want to do, Dan. This particular observation is a little bit well, not a little bit. It is 100% leveraging the extreme temperature gradient and then pretending that there is zero temperature gradient. So, all right, Dan.
Yeah, okay, go ahead, Dan. Dan, are you there?
I'm here.
If you had a rebuttal to that, Dan, go ahead.
Carnivore did it for me, and I already typed it, and they already didn't respond. They ignored what I said. So the reality is, the math would have to be some sort of progressive nature to be appearing at each distance more and more refracted somehow to a perfect level line across your horizon. Now that's just coincidental, I guess.
I can explain that. It is a progressive thing, and it is literally because the density gradient is the greatest close to the cold surface, and then it reduces with elevation.
Okay. So what you're saying is if they were 1.5 miles apart, that wouldn't have happened.
Just let me. No, I'm not saying that. I'm saying.
Well, you must be saying that.
I'm saying that. Just let me say it. It's not long. So things get lifted at first quite rapidly, and then less and less as it gets higher and higher. So it's called ducting. It literally puts them all in the same apparent plane because of the way the density gradient is, and it's a natural thing. That's just the way it would be.
Well, Jesse, in fact, if you were to raise the camera, you would still continue to see them. It's not in a level plane. It's being distributed in a wide range, right? It's not a pencil thin where if you move the camera off of the one position, you don't see it anymore. You see it all over the place at a very wide range of elevations.
Right. While you're in the duct, though, the duct has this interesting ability of making all those things appear at about the same height. Once you get out of the duct, then they'll start to appear at different heights in the field of view.
Now let's try this. I'm going to try a proof of concept. I don't have any frozen lakes around here. I live in the UK, and where I live, nothing actually freezes. So I'm going to do it on my road. So it's during the daytime. You can see the light. I've placed it in the spot there. The light is on, as you can see the video here. This is about midday. So as you can see here, put it down, and you can't. But just out of view. There you are. So my road is curved side to side because of the water drainage. So we'll say that's like simulating the curvature of the earth. So I'm going to mark it there so I know come up later on tonight and we'll put it down again. So there you go. Light's just out of sight. You can't see the light, can't see anything like that. So now here I am out at night. It's about 11 o'clock at night, and then we have the same light in the same exact spot. As I marked it there, I'm going to put my camera right back to where it was before, and look at that. You can still see the light even though it's actually over the curve. Sorry, my cover went over top, but there you are. So I actually have my camera light on, so I'll turn it off here in a second. There you are, and there we are. So now, even though that's the exact same spot where earlier today we couldn't see the light at all, or the flashlight, now you can see the light. It's actually diverging, and you can see it above the curve. This is the same concept that's on that frozen lake. Then I'm going to take some ice water here. Those are ice packs there. I'm going to put it down along here, and you'll actually see it's only a very short distance because we're only UK roads aren't very wide. We can go over here, but you'll see there is actually a bit of a difference. You'll see where the light actually is raised up a bit more. This kind of simulates the frozen lake. There's obviously ice cold water. Pick up my ice packs, throw them back in here. It's in between me and the light now. Put it exact same spot it was before, right on top of my paint mark, and we can see there you are. You can still see the light. It's actually above. Now I'll show you a comparison of a screenshot from before I put the water down and just after I put the water down. So as you can see there, proof of concept. This is exactly as they said in the video. So here you are, it's before I put the water down, and this is just after. You can see it's just lifted slightly up. This is proven. So there you have it, folks. The explanation was given there. It actually has to do with the divergence of the light over a frozen lake, cold surface, and it causes the light to curve a bit. And also, light diverges from the source, and like a big cone all the way around. Even if those were lasers, the divergence wouldn't be as big, but it would still diverge. It still get bigger, and that's proven. You can see that even lasers are rated on how much they diverge, and there's a rating. Obviously, more expensive lasers to go smaller, but every single laser actually diverges. You need like an infinite tube that would keep the light narrow to cause it not to diverge. But like that's why LIGO is so long, and it's because they need to keep that in a certain medium. But my little demonstration there, which is just out in front of my house, across the road, actually proved the proof of concept. And the fact is that during the day, you couldn't see that. You could see that that light was actually could not be seen over the curve of my road. But at night, with the light on, and at nighttime, that light is actually diverging, and you're able to actually pick it up. And that my phone was on my camera phone was actually on the ground, exactly the exact same spot, exact same way as it was earlier in the day. And so there you go. I have now debunked Nathan Thompson's best 2 flat Earth proofs, and they actually prove the globe, and it's explainable, repeatable, and demonstrable. So thanks for watching, and see you again.
I'm stupid. Like, do you follow me? And I'm just the biggest idiot ever and can't figure out when. Is that why you're here listening to what I say? Done.
I will be collecting many more flurf tears today.
Ah, yes. The good stuff. Always sweeten my coffee with the tears of flurfs.